In question A, we're given a Poisson random variable with parameter lambda t equals to p and t1, t2 equals k e to the negative lambda t times lambda t to the k divided by k factorial. And if t1, t2, and t3, t4 are non-overlapping, then the random variable mt1, t2, t3, t4 are independent, which we can then first find the expectation of xt, the random process of the Poisson random process. First, we know that the sum from k equals 0 to infinity of pxt equal to k is the sum from k equals to 0 to infinity of e to the negative lambda t times lambda t to the k over k factorial divided by k factorial and which then we can conclude that the sum from k equal to 0 to infinity of lambda k t to the k divided by k factorial equals to e lambda t. And then if we take the derivative with respect to lambda t, we'll have e to the lambda t, and then we can find the sum of from k equal to 0 to infinity equals k times lambda t to the k over k factorial equals to lambda t e to the lambda t. Then the sum from k equals 0 to infinity of k times e to the negative lambda t times lambda t to the k over k factorial is lambda t, so that the expectation of xt will equal to lambda t. And then in B, we have two conditions. First, if we have t1 over t2, and then because in the second part we are given that if the two regions are non-overlapping, then the random variable are independent. And at time moment t, if there are no more than one Poisson point, using point t I, we form the Stochastic process of xt in 0 to t. So first we have t1 greater than t2. We let ta equals to t1 and tc equal to t2, tb and td is 0, which almost looks like this. This is point A, this is point C, and this is point B, and this is point C, and this is point D, and this is t1, and this is t2, and we assume these are 0, and we can find that the expectation of e t1 minus 0 times x t2 equals to lambda square t1 minus 0 t2 minus 0 plus lambda t2 minus 0, because e of xta minus xtb times xtc minus xtd equals to lambda t1 minus equals to lambda ta minus tc times tc minus tb plus lambda square of ta minus tc and tb minus td plus lambda square tc minus tb square plus lambda tc minus tb plus lambda square of tc minus tb times tb minus td. So if we plug this back to the formula, we have lambda t1 times t2 plus lambda t2 minus t1, and it's the same process for t1 greater than t2 greater than t1. So we can conclude that our t1 t2 is lambda square t1 t2 plus the mean value of lambda t1 and t2.